Hello everyone, this is Dr. Nimish Kumar Srivastava, Assistant Professor in Electronics and Communication Engineering Department in the Ajay Kumar Garg Engineering College. So in this module of discussing about the complex topic related to a digital electronic, we were discussing about in our past video lecture we have discussed about the asynchronous counter, and in that too we have discussed about the up counter. Now in this we will discuss about the synchronous counter. Now before dealing with the synchronous counter, let us first try to build the concept of related to the down counter. So we will first discuss the down counter and then we will quickly move to the concept of the synchronous counter, how we can design, what is the operation of the synchronous counter. So at this point we have ended in our last lecture. So let us try to quickly have the concept of the down counter, asynchronous down counter. And in the last class we have discussed the mod 8 up counter. So in this case we will discuss the mod 8 down counter. So we will first try to write the name of what we are going to discuss. We will discuss mod 8 down counter. Now in this case, let us quickly build the circuit, and after that we will draw the table of the counter. So we are having a J2, K2, Q2, Q2 complement. Both input are 1 1. We are applying a clock. This is a positive edge triggering. Similarly on this side we are providing the clock as an input to flip flop 1 by using output of the flip flop 2. This is J1, K1, Q1, Q1 complement. This is J1, sorry, this is J0, and this is K0, this is Q0, this is Q0 complement, and finally this is my output. Both the input are 1 1. This is also 1 1. If I am considering it as a second flip flop, first flip flop, 0th flip flop. So based upon this I will try to visualize whether this is a down counter or whether it is a up counter. So till now I don't have this point whether I can easily conclude that this design is a down or a up counter. We will not discuss that tricky point. So we will first try to get the output and then we will conclude that this counter is down or a up counter. And in our next point we will discuss about how by just visualizing the circuit we can conclude that this is going to be a down counter or whether any other circuit going to be a up counter. Now again the same concept for the ripple counter. Whatever the flip flop or whatever the flip flop on which we are applying the external clock pulse, that will be treated as a LSB. So we will consider LSB as Q2, Q1, and then our MSB will be Q0, and based upon the clock we will see how it is reacting. Again we will assume that our entire flip flop is holding the value 0, or we can say that entire flip flop is in the reset state. So let us try to assume those combinations. Entire value is 0 0 0. Now next case is we are going to apply a clock pulse, and that clock pulse is going to be applied on the flip flop 2. And which type of a triggering is this? It is a positive edge triggering. So based upon, as we have applied the clock pulse directly to the flip flop 2, so whenever we are applying a clock pulse it will react, and based upon the input combination it will produce the output. And we have considered the combination 1 1, because we know that what is the point of differentiation between a synchronous and asynchronous counter based upon its operation is that asynchronous counter is totally based upon the toggling operation, synchronous counter is totally based upon the next state equation or next state values. So keeping that point, we will observe the output. So based upon the first clock pulse, your flip-flop 2 going to change its value from 0 to 1, right? Now for flip-flop 1, which is a positive edge triggered, means that it going to react based upon the input combination only when it is seeing a transition from 0 to 1. So only when it is seeing a transition from 0 to 1, it will react, while in a transition from 1 to 0, it's not going to react based upon the input combination, and it will hold the past value. So for flip-flop 2, the value is toggled and it is changing its value from 0 to 1. For flip-flop 1, again it is a positive edge triggering because it is seeing a transition from 0 to 1, because the clock pulse of the output of a flip-flop 2 is applied as a clock pulse to the flip-flop 1. So means that it is seeing a transition from 0 to 1. So means that it will toggle the value, toggle the past value. Past value was 0, so now present will be 1. Again for flip-flop 0, it is seeing a transition from 0 to 1. It is a positive edge trigger, so it is seeing a transition from 0 to 1, and based upon that it will react on the input combination, and input combination is 1 1. So it will toggle the past value. Past value was 0, so now it will become 1. Now let us see for the next clock pulse. For the clock pulse 2, again your flip-flop 2 going to react, it will change its value from 1 to 0. But for flip-flop 1, the output of a flip-flop 2 is acting as a clock for the flip-flop 1, and it will react only for transition from 0 to 1. But there is a transition from 1 to 0. Means that it's not going to react based upon the input combination, and it will hold its past value, past output value. Past output value was 1. So again it will hold the past output value, and this will also hold its past output value. Now let us see the combinations for third clock pulse. For third clock pulse, as we can see from this table, your flip-flop 2 will toggle its past value, become 1. Now your flip-flop 1 seeing a transition from 0 to 1, it will also toggle its value, changes to 0. But flip-flop 0 is seeing a transition from 1 to 0. So it's not going to change the value, it will hold its past value. For fourth clock pulse, again flip-flop 2 changes value. It's changing its value from 1 to 0. It will hold its past value. This will also hold its past value for 6, 5, 6 and 7. Now for the fifth clock pulse, again flip-flop 2 changes value to 0 to 1. This will also react, toggle its value. This will also react. Your flip-flop 0 will also react, toggle its value. Count changes to 3. Now at the sixth clock pulse, again flip-flop 2 will toggle its value. Flip-flop 1 going to hold its value. Flip-flop 0 will also hold its value because it is not seeing a transition from 0 to 1. It is seeing a transition from 1 to 0. Now at the last clock pulse, for sixth clock pulse, again your flip-flop 2 going to toggle its value. It will change its value from 0 to 1. It's seeing a your flip-flop 1 is seeing a transition from 0 to 1. So it will also toggle its past value. Past value was 1, becomes 0. And for flip-flop 0, it will change its value because it will hold its value because it is seeing a transition from 1 to 0. So it will also become 0. Now at the 8th clock pulse, what will happen? At the 8th clock pulse, we will see that again your flip-flop 2 will toggle its value, change its value from 1 to 0, and as it is seeing a transition from 1 to 0, so your flip-flop 1 will hold its past value, flip-flop 0 will also hold its past value. So means that you have now entered into the initial state. At the 8th clock pulse, you have arrived at the initial state. So what are the different possible combination? What are the different possible states? Sorry, it is changing from 7 to 0, as this is a down counter. So it is changing from 7 to 0. So means that total combination is 8. Total possible states, total different states are 8. So means that this is a mod 8. down counter. From this we can conclude that this is a mod 8 counter, and as it is counting in a descending order, so that means this is a mod 8 down counter. So it is mod 8 down counter. Now we have discussed the point for the asynchronous counter. Just by building the table, we are concluding that whether this is a up or whether this is a down counter, and from the table also we can conclude the mod. Mod means different possible states for that particular counter. So now with this tedious process, although this is not a tedious process, it is a conceptual process, but one should be very sure about whether the output result going to be right or wrong, just by remembering one tricky point related to these counter. We can conclude that whether that counter is down or up counter, and based upon that, once we are assured that your counter is a down counter, so you will quickly keep on changing the values based upon the clock pulse, and it will consume less time without even observing. So now the next thing that we will discuss about the how we can conclude that my counter is a down or up counter. So we will try to build a different circuit, and based upon that we will conclude. We are considering it as J0, K0, Q0, Q0 complement. Both input are 1 1. This is your clock pulse, and similarly this one is also J0, K0, Q0, Q0 complement. This is also J0, K0, Q0, Q0 complement, and this is clock pulse, and here we are considering positive edge triggering. Now in this case we will take the output from Q0 and put it at the input clock pulse of J1 K1, J1 K1, Q1, Q1 complement, and on this side we are taking the output from Q0 complement, and we are taking J1 K1, Q1, Q1 complement, and on this side we are taking the output from Q0, giving it to the input of the flip-flop 1. This is J1 K1, all the values are 1 1. This is also 1 1, and it is Q1 Q1 complement, and on this side also we will have the same fashion in this way, and this is a positive edge trigger, so it will be like this: 1 1 1 1. This is J2 K2, J2 K2, the last one J2, K2. Now, and the finally output will be Q2, Q2 complement, Q2, Q2 complement, Q2, and this will be Q2 complement. So this is my output. Now we are left with one more combination, so we will quickly draw that combination and then we will conclude. So we are having another combinations, the same thing as positive edge triggered. So in the last case we have taken the output from the positive terminal. So this is my clock 1 1 J0 K0, and this is Q0 complement. This is also positive, but from here we are taking the clock pulse from the complemented value. So it is J1 K1, and this is J2 K2 Q2 complement. So this is, we are going to take as the clock. This is Q1 complement, this is Q1, and this is my output. Now, just by seeing the figure, how we can conclude about the whether my counter going to be a down or whether my counter going to be up counter. So just for remembering this point, this is not actually happen, but just for these are some tricking point that you have to make by your own, so that you can conclude that your counter going to be down or up. So in this we are considering Q0 as my positive output, and what if I am considering Q0 as my positive output, my Q0 complement will be negative output. So my Q0 complement will be negative output. I think this is not visible, so we will try to write this point here. I have considered my Q0 as positive and Q0 complement as my negative, and this bubble we are treating is as a negative edge triggering, and if it is not a bubble, so that means we are treating it as a positive edge triggering. So that means bubble will be treated as a negative, and without bubble will be treated as a positive. So in this case, what is happening? Just observe the sign of a clock pulse for the subsequent flip-flops or for the adjacent flip-flop. So in the flip-flop 1 and in the flip-flop 2, as we are seeing that the sign with which your negative edge triggering is connected is your positive. So here we can assume that this is positive and this is negative. So remember that opposite sign give me up counter. Opposite sign give me up counter. What about the next case? Here it is negative and here also it is negative. So means that we are having same sign. So same sign going to give me down counter. Same sign going to give me down counter. Down counter. And we have discussed these two situations also. Right? So as it is a same sign, it is going to give me a down counter. Now let us discuss about this one. For this. So this is your which sign? Positive, and this is also positive. So positive is connected with the positive, means that you are connected with the same sign, means that it will be a down counter, and we have discussed this point in our previous lecture also, or in our previous slides also, that we have discussed this operation by using a table, and we got that this is a down counter. So as this is a same sign, so again it will be a down counter. Now the last case, this one. Here it is negative, but here it is positive. So that means this is opposite sign. Opposite give me opposite sign, give me up counter. Now these type of tricky points is very useful in the case if you are attempting for different competitive exam, like different MCQs and like in your GATE or even in different PSUs. So something can be asked based upon these combinations. So a circuit will be provided and they will ask you, they will give you this counter is of which, this is a mod 8 down counter, up counter, or a mod 7 up or a mod 7 down counter. So based upon the trick, you will just conclude that this is going to be a up counter. So that means you can easily eliminate the two combination. You can easily eliminate the two options, and with the remaining two you can easily get your correct result. Now, so with this point we are going to discuss the we are going to very quickly discuss about the synchronous counter, and that too a ring counter. Synchronous counter, and in that synchronous counter we will discuss the ring counter. So in the ring counter we will take the example of a, we will try to take the example of a D flip flop. So we have taken the D flip flop and we are providing, as this is a synchronous, so everything will be attached with the same clock pulse. So this is your output, and as this is a synchronous, so means that we are going to take the output of the last flip flop and provide it as an input, as a feedback to my D2. Or even if I am not writing D2, it's not going to put effect. So this is my Q3 complement. This is connected with this, and this is my D2, this is my Q2, Q2 is connected to this way, and this is my D1, and this is my Q1. Fine, and this is my clock pulse. So in this we have to observe the output. So remember, while applying the, while discussing or while visualizing the basic operation of your synchronous counter, just first try to draw this table. So we will draw the table between clock, present state, then flip flop inputs, and then next state. So these are the things that we have to draw. So in this case, present state, as we have considered, present state is Q3, Q2 and Q1. So this is Q3, Q2 and Q1. Now for the flip flop 3, what is the input? Input for a flip flop 3 is D3. Sorry, it is not D3, but it is input for a flip flop 3 is the feedback from output Q1. So for D3, this is because this is input, so D3 value will depend upon the Q1, right? Similarly, for flip flop D2 input, how it is connected? It is connected with the output Q3. Similarly, for flip flop D1, it is connected with the output Q2. So this is my flip flop inputs. Now based upon this, I will write the next state equation. We will try to draw the next state equation. So when no clock pulse is applied initially, we are assuming that my output is 0, 0, 1. right? We are assuming that one of my output is 1, because we have to understand that after how many state my flip-flop going to arrive at this initial counting. So based upon this, we will try to write the flip-flop inputs. So D3 is having Q1, so it will be 1, and D2 is having Q3, it will be 0, D1 is having Q2, it will be 0, and my next state will be Q3 plus, Q2 plus, and Q1 plus. So my next state is totally based upon my flip-flop input. So for Q3, the input is 1, that means output will also be 1. For Q2, input is 0, output will also be 0. For flip-flop 1, input is 0, so output will also be 0, because this is a delay flip-flop. Just copy the value. So this next state on application of first clock pulse will come as the feedback and will be treated as the present state. So that means 1 0 0 will now be present state, and with this we will again write the input, flip-flop input. So D3 is having Q1, so Q1 is 0, and D2 is having Q3, it will become 1, D1 is having Q2, it will become 0. So based upon my input, I will write the output. So for Q3, the D3 is 0, so it will also become 0, and for Q2, the input is 1, it will become 1, and for D1, that Q1 input is 0, so it will also become 0. Now this becomes the, on application of next clock pulse, it will become the present input, this 0 1 0. Now let us see the draw the input. So flip-flop 3 is having Q1 as an input, it will become 0. D2 is having Q3 as an input, it will become 0, again this will become 1. So based upon the input, my output will be 0 0 1. Now this will be treated as a present input, so it will be 0 0 1, and based upon this, D3 will have a Q1, it will become 1, D2 is having Q3, it will become 0, and my D1 is having Q2, it will become 0, right? So at this point, what is the output? At this point, my output is 1 0 0. Fine. So what is the different possible states? I have considered my initial state as 1, and after how much or after how much clock pulse, or the better word is what are the different possible state through which your counter is just encircling so that it get to the initial state. So initial state was this 0 0 1, and we can see the counting is moving from 0 0 1. This is first state, this is second state, and this is third state. So means that this is your mod 3 counter. This is your mod 3 counter. So we can also conclude that what are the different state possible for this ring counter. We have considered the example of a ring counter. So by using n flip-flop, we can have n states, or if we are writing it by a capital N, we can have n state. N is the number of flip-flop. So my flip-flop is 3, my total state will be 3. If my flip-flop is 4, my total state will be 4. So that is the concept related to your synchronous counter. So we have taken the example of a ring counter of the in the case of your synchronous counter. So that is all about your synchronous counter. So in this lecture, we have discussed the two things about the asynchronous and in the synchronous counter. So in the asynchronous, we have discussed the two types, that is a down and up counter, how we can conclude just by observing the circuit diagram that whether it is going to be a down or whether it is going to be up counter. And based upon that, next thing that we have discussed is the synchronous counter. And in the synchronous counter, we have taken the example of a ring counter. So in the ring counter, the basic concept will be the output of the last flip-flop going to be connected as a feedback and given as an input to the first flip-flop. So that is the synchronous counter, and we have discussed the operation, how we can conclude that what is the state of this counter. So just remember that in order to get the working principle, just try to first draw this table. So once you have drawn this table, you can easily get the right result. So that is all we have discussed in this lecture. So thank you all for watching this.